guys, welcome back to my YouTube channel. Today I am going to solve day 15 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 2196. Create binary tree from descriptions. Okay, so in this problem you are given a 2D integer array descriptions where descriptions of I contains parent, child and is left. Okay, indicates that parent I is the parent of child of I in a binary tree of unique values. Furthermore, if is left I value is equal to 1, then child is the left child of parent of I, and if is left I value is equal to 0, then child is the right child of the parent. Okay, and we have to construct the binary tree described by descriptions and return its root. Okay, so I hope that this problem statement is clear. Okay, so now see this example number 1. Okay, so here see, first value is nothing but my parent. Okay, so first is parent. Okay, so let me create this parent. Okay, it is not there, so I have created this parent 20. Now second value is the child of this parent. Okay, and here is left value is 1. Okay, so if is left value is equal to 1, then child is the left child of parent of I. Okay, so this is parent and this parent's child is 15 and is the nothing but the left child of this parent. Okay, because is left value is 1. Okay, now again parent is 20, child is 17, and here is left value is equal to 0. Okay, so that simply means that this 17 is the right child of 20. Okay, I hope this is clear. Now let's iterate over here. 50, 20, 100. 50 is the parent and this parent 50 is the parent. Okay, so 50 is not there, so let's create this 50. Okay, and this 20 is the, this value is 1, so this 20 is the left child of 50. Okay, this is done. Then parent is 50 and 80, and here 0 is given. Okay, so simply this simply means that 80 is the right child of 50. Okay, so let me draw it 80. Okay, now we move to this position. 80 is the parent, 19 is the child, and 1 simply means left. Okay, so 19 is the left child of 80, right? And this is done. Okay, now in the end you guys will see that there is no parent for this node. There is no parent for this particular node. Okay, so this is going to be our root node. Okay, the node which has no parent is going to be our root node. Okay, so root node is the node with value 50 since it has no parent. Okay, and this is how our resulting binary tree is going to look like, right? And in the end we are just returning the output. Okay, 50, 20, 80, then 15, 17 and 19, and that's it. Okay, so this is what we are returning. Okay, so I hope that you guys are clear. Okay, so now let's see how I'm going to solve this problem. Okay, so this is the example one, right? So here I am going to create one set. Okay, I am going to create one set. So let's say this is my set. In this set I am going to add the child nodes, like all these nodes, 15, 17, 20, 80 and 19. Okay, this is my set, and also I am going to create one map. Okay, so let's say this is my map. Okay, so let's say this is my map. Okay, and in map, in this side I am storing the integers. Okay, and in this side I am going to store tree nodes, and let's say the name of my map is nothing but node map. So now let's see how what I'm going to do. So first, this is the value, right? 20, 15 and 1, this is the value. So first thing here, we know that this 20 is nothing but parent. Okay, this 20 is nothing but my parent, this 15 is nothing but my child, and this 1 is nothing but is left value. Okay, so here first thing that we need to do, we need to check if this 20 key is present in my map or not. Okay, so right now it is not present. Okay, so if this key is not present, then what I'm going to do, I'm going to put this key in my map. Okay, 20, and here I'm just going to create the node of this 20. Okay, so this is how I have created the node. Okay, so here I have inserted 2, 0. Okay, this is done. Okay, then after that I am going to check if this child is available in my map or not. So this child is not there in my map, right? So I have added this key and I have created a node for this 15. Okay, so I have created a node. Okay, this is done. Then after that I'm going to check what is this value is left. So here is left value is equal to 1. That simply means what we need to do, we need to insert this 15 in the left of this 20, right? This is what we need to do. So what I'm going to do, I'm going to use this node map dot get this parent. Okay, I go to this parent and in this parent I get the value. What is the value here? 20. Okay, this is the value. And now in this value 20 I am going to add 15 to its left. Okay, so I have added 15 here. Okay, this is done. Okay, this is done, right? Now after that I move further. 20 is there in my map. Okay, and node is also created, so we don't need to do anything. 17 is there in my map? No, 17 is not there in my map, so I have to create one new key 17, and here I am just creating the node of this 17. Okay, 17 node is like this. Okay, this is done. Okay, so now let me draw it like this. Okay, here let me remove it from here. So see this outside. Okay, in 20 in the left side of this I have added 15. Okay, see here. Okay, that's it. Now see, now is left value is 0 here. That simply means that this is going to be the 17 is going to be the right child of 20. Okay, so what I'm going to do, I'm going to go to this map, node map dot get parent, yes, this parent, and then go to the right side of this value. Okay, so in the right side of this value I am going to place 17. Okay, this is done. Okay, now after that I go to this position. 50 is there in my map. 50 is not there in my map, so I have to create a 50 key, and here I am just going to create this node, 50 node. Okay, this is done. Then 20 is there. 20 is there already. Okay, now 1 simply means that this 20 is going to be the left child of 50. Okay, so what I am going to do, node map dot get parent, parent is 50. I go to this value now, node map dot get parent simply means that this value 50 node. Okay, and in this 50 node, okay, so here this is the 50 now, so in its left I am going to add this value. Okay, 20, this one 20. Okay, node map dot get the childs, so we have this value, right? So see, this is my parent. Okay, this is my parent. Okay, this is my parent. Okay, so in this parent I am adding this child's value. Okay, so we already know the child's value of this one. Okay, 20 is like this only, 20, 15, 17. Okay, all these values are already there. Okay, so how this is working, see here, node map dot get parent. Okay, so here I go to this position now, node map dot get parent is going to give me this node value 50. Okay, I'm going to add in the left side of this, right, is equal to node map dot get, and now inside this get I have to write child, right, child. So what is a child of this 50? This 20, and this 20 already contains all these things. Okay, 20, 15, 17, it's already there. Okay, so this is the formula that I'm going to use. Okay, okay, so this is done. Then after that we reach at this position, 50, 80, 0. 50 is already there, I don't need to create any node. 80 is not there, so I have to create the tree node for this one. So here I have created the tree node for this 80, and 0 simply means that this 80 is the right child of this 50. Okay, so here see what I'm going to use here, node map dot get parent. Okay, here I reach to its right, I have to add node map dot get child, and node map dot get child is nothing but 80, and this value is just 80 only, so here I have added 80. Okay, that's it. Then I reach at this position. 80, this key is there, I don't need to create a node. This 19 is not there, so I have to create the node for this 19 first. Okay, so I have created the node for this 19. Then after that 1 is there. 1 simply means that this 19 is the left child of this 80. Okay, so what I'm going to do, node map dot get this parent to its left is equal to node map dot get this child. So 19 for this one, this is the value only. Okay, so this is how I am going to create binary tree. And side by side, one more thing, in the set I have told you that I am going to add the childs one by one. So here in the set I have added 15, then this 17, then this 20 I have added, then this 80 I have added, then this 19 I have added. Okay, so now after that what I am going to do, okay, once this is done, this 20 is the children, so this 20 is here and this 20 is also here. Okay, this 20 child is here in the keys of my node map, right? So here I am not going to use this 20 as my root. This 19 is there, this 19 is the child, and this child is there in the this value, okay, in the key of my map. So I'm not going to use 19. This 80 is there, this 80 is there. Okay, so now I'm not going to use this 80 in as the root. Okay, this 15 is there and this 15 is here as well. Okay, so I'm not going to use this 15. This 17 is here, okay, and this 17 is here. Okay, this 17 child is here and this 17 child is here in the node map. Okay, so I'm not going to use, so only left out value is 50. Okay, so I'm going to treat this 50 as my root. Okay, and in the end I'm just going to return the root. Okay, so that's it, that's what we need to do. Okay, so now I'm going to move to the coding part. So first create one map, and in the map I have told you guys that I have to add integer and then nodes, 3 nodes. Okay, let's name it as node map is equal to new hash map, and then we have to create one set as well, right? And in the set I'm just going to add the children's integers only. Okay, integer, and in the end I was just matching this integer with this integer. Okay, and if any integer from map is not matching with this set, then definitely that is going to be my root. Okay, that's what I'm doing, right? So here I'm just writing child nodes, new hash set. Okay, this is done. Then after that let's iterate over all the descriptions one by one. So I'm going to use for each loop int description of descriptions. Okay, and you know that first I'm going to pick this now. So 20 is going to be parent, this is going to be child 15, and this one is going to give me the is left value. Okay, so here I'm just going to write int parent is equal to description of 0, int child is equal to description of 1, and boolean, let's use boolean, right? Boolean is left. Okay, boolean is left, I'm going to get it from description of 2, right? This is clear enough. I am writing 0, 1 and 2. Okay, so this is 0th index, this is 1 index, this is 2 index. Okay, so description of 2. Okay, this is going to be true if the value is equal to 1. Okay, then that simply means that I have to add the child in the left of my parent. Okay, now after that I am saying that if this key, this parent is not available in this node map, then I have to create the node for this one. So, okay, so let's do that. So node map dot put if absent. Okay, node map dot put if this particular key is absent. Okay, parent. Okay, then I have to simply create a new tree node, and here inside this I have to just add the parent. Okay, that's it. Now again copy paste, same way I have to do for the children as well. Okay, so if the child is absent from my map, okay, then I have to create a new tree node, and here I have to just insert the child. Okay, so see 20 was not there, so for this 20 key I have created this tree node. 15 was not there, so for this 15 key I have added this tree node. Okay, this is done. Then after that let's check if is left is there or not. Okay, so if is left. Okay, if this value is true, then simply means that I have to add the child in the left side. Okay, and in the else part, if it's not true, then definitely this means that I have to add the child in the right of my parent. Okay, so now if it is left, then what we need to do? Okay, so here see, logic is very simple. Okay, so what is my map? Node map. Okay, node map. Okay, now from node map, let me get the parent. Okay, so here I have get the parent. Okay, so here see, I am going to get the parent. Okay, that is nothing but key, and key is nothing but integer only. Okay, for this integer. Okay, so see, node map dot get parent. Okay, and here I am inserting key, so definitely this simply means that I am going to get the value for this parent. Okay, so for this 20, what is the value? This 20 node is the value for this. Okay, so node map dot get key is going to give me the parent. Node map dot get key is going to give me the value. Okay, so in this value, okay, in this value I have to place the child in the left. Okay, so that is why I'm writing left here. Okay, this is done. So now for this 20, I get this 20 value, and now I go to this left. Okay, now in this left, what I need to do? So in this left, I am just going to get node map dot left, and here node map dot get and here I'm just going to get the value of the child. Okay, what is the value of my child? That's it. So here child value is 15. For 15, node map dot get child is going to give me for this key this value 15. So here I'm just adding 15. Okay, that's it. That's what I'm doing. Okay, same way for right, we need to write. Okay, so if is left value is not true, then I have to just place the value in the right. Okay, that's it. So simple, right? And side by side, let's do one thing now. In the this is my set now. So what is my name of set? My set name is child nodes. Okay, so in this child nodes, let me do one thing. Let me add the values of children. Okay, so that in the end we will find the root. Okay, so that's it. Code is very simple. That's it. Now we have to just, in the end, we have to just iterate over all the node map keys one by one. Okay, so here for int parent node map dot key set. Okay, and inside this, if this set name is child nodes. Okay, child nodes doesn't contain this specific parent, then definitely that is going to be the root. Okay, so here I am just going to return node map dot get, and here just pass this parent as the key. Okay, for this parent I'm going to get the roots. Okay, this is going to be my root. Okay, simple this means. Okay, root node. So here this is nothing but my root node. That's it. And in the end, just return a null just in case. Okay, that's it. Now let's run the code and see if there are any code issues. I think some spelling mistake. Description. Let's run it again. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n, because we are just iterating over all the descriptions one by one, right? That's it, what we are doing. And here also we are just moving over the keys one by one. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.